Alright, so today we're going to be going through different types of code blocks. So starting off, we have conditionals. So this is our objective right here. We want to calculate what their mark will be based on their percentage. So first we need to get the input. So we'll do mark is equal to int input. And then now we need to write some conditionals. So there's three main keywords in Python. There's if, elif, and else. So we start off with if. So if their mark is equal to 100, so if their mark is equal to 100, then print out a plus. Pretty standard stuff. Now we can still use an if over here, but that will be really bad for performance because pretend we have a bunch of these if statements over here, then it's just going to clutter up the code. And it's going to be less efficient because Python is going to check all of these if statements rather than the more efficient solution where we use elif, which stands for else if. And what elif does is if this is not met, if this is not true, then it won't run, and instead run this. So elif, our mark is greater than 90 or greater than equal to 90, then print out a. And we can also continue this chain down using elifs, and this is more efficient because let's say if they get 95, then it will stop over here rather than checking all of the statements and code blocks. So let's just follow this pattern down. Okay, so I've written all the statements for these things, and the benefit of using elif is we don't need to specify a range because it'll simply go down. So instead of having to specify range, we can just go down and check if it's greater than the number on the right. Otherwise, if we used if statements, we'd have to specify a range, and that's harder to think about. It's less Pythonic. So elifs are just better in this scenario. So now let's code the else block over here. So we use the else keyword, which says that, hey, if none of this is met, then follow this code block over here. So we want to print f, because if the mark is less than any of this, then that means they have failed, basically. Now it's important to note that you can't have elif or else without if. You can have just if, you can have just if else, you can have just if elif, but you can't have just elif else by themselves. So now let's save this program and let's run it and see how it works. So it's asking for our input over here. So let's put in 95 and it prints out a, which corresponds to our range over here. But there's one problem with this program, and that's that if you put something else that's not a valid integer, then it won't be able to convert it into an integer, which is a problem. The code is just going to crash. So in a real world scenario, we need to put error handling. Okay, so let's just clear this up, and now let's try putting in error handling. So basically, what do we want to do when we handle these errors? Well, if the input is not an integer, then we just don't want to run this section over here, right? So we have three keywords here: try, except, finally. So let's put this code in a try and except, and talk about the code in just a second. Okay, so we wrapped it in a try except, which you need to put except with the try. And what this means is, hey, let's try out this block of code. If it works, well, it works, just skip over this part. But if it doesn't work, stop running this try block and run this except block instead. So let's go ahead and run this. We can see that it already works like normal, right? It still says A. But if we run this again and we put something else that can't be converted, it says code failed, input was not a valid integer, because now this is resulting in an error, so it's using except instead. One important property to note is that except, using try and except is slower than using an if statement. So if you want to brute force something that's worse because A, it's less readable, and B, because it is slower in execution time. So stick to if and else's instead of brute forcing try and excepts whenever you can. So this is good, but our code just fails, and we don't want it to just simply say code failed, impose not a valid integer. No, instead what we want it to do is continuously run until it does get a valid integer, and then end the program when it gives us a valid result. So let's try incorporating that. Alright, so we want to basically put all of this code in a loop. But before we do that, we need to learn loops. So there's two loops in Python. There's the while loop and the for loop. So let's go through each of them, starting off with this while loop over here. Okay, so this over here is a while loop. And basically what's happening is we set a variable to true, and we are like, while this variable is true, keep on running the loop. That's how loops work. While a condition is met, it will run a loop. And it basically takes an input, and then if that input corresponds with, if that input is A, which we specify over here to stop the program, then it will set that variable to false. So let's go ahead and run this. Hi, type A to stop. So I just put something else. It won't stop unless I put A, in which it does stop. So there are some optimizations you can make here, like just making this directly while true. And we can incorporate some other words into here, notably break. So let's talk about this just for 1 second. Let's keep this program. So what is while true and break? While true is going to keep on running forever until you break the sequence. What break means is it breaks the loop that it's in. So if we run this program, we can see how it acts the exact same, and it stops when an A is typed. And that's because we were using this break keyword to break out of this loop. So if we try using the break keyword outside of a loop, you can see that it's resulting in an error because that makes no syntactical sense. So using break is very, very useful when it comes to loops, especially when you want to keep on doing an action until something is met. Now break works for both for and while loops, but there's another keyword called continue. So what continue does is it skips over the rest of the lines in the program, and instead it goes to the next iteration. So while we're talking about continue, let's put another line of code. And now let's run this program. So if we type H, you'll see how it says code is looping. And that's because it keeps on looping. And then if we type A, it won't say code is looping because it's just continuing to the next iteration of this loop and skipping the rest of the code afterwards. So remember break and continue. Now while loops are very useful, and they are especially useful when you don't know when it's going to end. But if you do know when it's going to end, you want to use a for loop. So I will close this, and actually I'll comment this out. So what are for loops? Well, for loops are in this form. They iterate over something. So for I, that's what we usually put. You can put anything here, this, but we usually put I for iterator. For I in range, and then you can put a number here. I will talk about the range in just a second. Let's just print I for now. Okay? So you can see how it's printing all the numbers here. So I just introduced a lot of concepts here, but let's talk about what's happening in just a second. So I, that's the variable, and that is being assigned to whatever can be iterated over. So lists and strings can be iterated over. So let's just for an example, let's print out range of 5. And you can see here how it shows a list of numbers here, 0, 1, 2, 3, 4. So basically what this for loop is doing is it assigns a variable to each number in this list. So for I in this thing, for each number in the list, print out that number. And it continues until it gets to the end of what is being iterated over. So in this case, the last number it would print would be 4 because that's the last item in the list. So now for this range function over here, there's three parameters that you can provide. So by default, there is just one parameter here, and this is the end number. So the loop will stop when it gets the number one below this, because just like strings, it starts from a 0th index. If you remember that example, it said range of 5, and it provided a list of 0, 1, 2, 3, 4. So it goes from 0, it counts it, and then it goes to 4. So that's an interesting quirk you need to remember when dealing with range. You can also provide a end. So let's say we want to make the range 2 to 6. So let's clear the terminal and print this out. So you can see how it says 2, 3, 4, and 5 because it's counting the first two and it's going up until 6, but it excludes the last number. And then there's also step. So if you remember, this is similar to how strings and lists work from the previous episode, where the first is inclusive, the last is exclusive, and this is the step. It's the same way. It works in the same exact fashion. So for loops are much faster than while loops because these are written in C. So whenever you can, use a for loop, especially when you know when the loop is going to end. And in fact, it doesn't have to be just this range. Like I said, you can iterate over anything. So let's iterate over spells. For spell and spells, we don't have to use I here. So for spell and spells, we want to print out that spell. So ice, dark, and fire. And you can also iterate over a string, for example. We just do that. It will iterate over it and it will print it all out. Now, in many cases, you want to see the length of something, and we already sort of covered this keyword, but we can use the length keyword, or len, and put spells, and this will return the length of the list. So when you feed this into range, you will get the length of this. And in fact, what you can do here is, since this is a list, you can also print out everything in the list by writing the index instead of iterating directly over each item. So that's also another cool trick you can do with for loops. Now, if you want to incorporate that for loop logic in this while loop, since sometimes it is easier to think using a while loop, what you can do here is, let's say we set I to 0. Let's just go ahead and delete all of this. And we want to make it so while I is less than 10, print I, wrong symbol there, so we don't end up in an infinite loop. And there is a problem if you end up in an infinite loop, then your code will crash. And if you do set it into an infinite loop, stuff like this will happen, which is really inconvenient. So make sure you don't set it into an infinite loop. That's why for loops are better. That's usually mitigated most of the time. So these are the basics of loops. Now let's see how we can incorporate this in this program over here. Like I said, we want to keep on asking the question, hey, what's your mark? If the user provides something invalid. So what can we do here? We can put this in a while true loop. So we have to indent this to go under. And then if this is valid, that means we got a good number. So actually, this while true, we should make this something like done is equal to false. So while the program is not done, we will keep on trying to run this. And then if it is done, make it so done is equal to true, which will negate itself. So it will cut the loop. And then we'll write at the bottom, print program is finished. So now let's run this, and it's going to ask for a number. Now let's just put 5. It says F, program is finished. And let's say we don't put anything valid, then it'll say code failed, input was not a valid integer. It's going to want some more input, and it will keep on doing that until we do give it some valid input, in which it will say program is finished. Just one more thing before I end off today. There's also a useful feature you can do called generators. So let's say you want to generate squares. You want to generate the squares and numbers. So we can make that a variable. Squares is equal to. let's put brackets here just for now. And let's make a for loop to print it all out. So for I or we can do for num in squares, print squares. So if we want to generate the square of numbers, multiple squares, we have to use something called a generator, and it uses a for loop here. So we're just going to add this on, generators, and also just continue and break since we already covered that. So let's create a number here, which is the max number. So let's just set that to 5 for now. So we're going to write it in the form of square, or actually we're going to do base times 2 for base in range, and then max num plus 1. Plus 1. So what are we doing here? Well, we have this for loop sort of set out. It's using a very different form than what we just explored. Stick with me here for just a second. So what's basically happening here is it's generating something to iterate over. You can also use something else here if you want, but it's iterating over this range, and we want to include this last number. So that's why we are adding 1 to it. So we are generating a list of numbers, which are the bases. And then what we're doing is we're squaring those bases, and that's what will be returned into each item in the list. So now it will help a lot if you actually see what's sort of going on. Oh, sorry, I didn't meant to do that. I meant to put num. But you can see how it's printing each number over here. And it's generating each of the numbers because the base is being multiplied with itself, and the base is being pulled from an iterable list of numbers. Now, if you want to be fancy with it, you can also put single line if statements. And now, if you are working with multiple, I would say if it's not just a simple one line for loop, I would say break it up into multiple statements. But if you really want to be adventurous, you can put an if statement here as well. Okay, so we added this part at the end. If base is not a multiple of 2, so that means 1 divided by 2 has a remainder of 1, then add it to the list. So you can see how we've gotten rid of this 4 and this 16 over here, because those are even numbers. So you can do that, or even if you want to do single if statements, you can also do it. It's just in form of the result if condition else like other result. So it's using a more confusing syntax, and I would say for a beginner level, don't really use this. Just stick to multiple lines unless you're using generators, since generators are nice and concise. But otherwise, it's just there for your knowledge. So it's the end of the episode, and I just want to thank you guys for the support I've been receiving. It's really encouraging, and it's helping me out a lot. So until next time.